For a web developer, the gamble of a WordPress migration often feels like this. You hit deploy and wait to see if it shatters. That fear is rooted in reality. Moving a standard WordPress site requires transporting a delicate ecosystem of PHP scripts, SQL databases, and third-party plugins that are all deeply interconnected. In a traditional setup, the origin server must rebuild every page from scratch using these scripts each time a visitor clicks a link. This reliance on live database processing makes traditional WordPress vulnerable to speed crashes, traffic overloads, and the specific errors that cause migrations to fail. Caching plugins and managed hosting upgrades only mask these symptoms. They do not address the underlying architectural weakness. To prevent these failures, we have to identify exactly what breaks at the technical level when a dynamic site is pushed to its limits. There are three primary threat vectors in any migration: SEO data corruption, dynamic interactivity failure, and the content sync bottleneck. Analyzing these failure points reveals the technological gap between a broken migration and a high-performance transition. Neutralizing these threats requires decoupling the live database from the public-facing website. The first threat is the loss of organic traffic. When a transition breaks URL structures or drops metadata, Google's rankings for that domain can plummet. This occurs when static exports strip out canonical tags or fail to port over the complex JSON LD schema markup required for search engines to index the site properly. Nimbica prevents this through automated SEO enrichment within the static edge pipeline. Within the recent deployments log, the system tracks the successful execution of each build, ensuring metadata is injected into every page. The site's technical health is then verified against search engine standards, as seen in this past status for Core Web Vitals. The result is a perfect 100 performance score on Google's desktop evaluation, proving that the underlying code remains optimized for search. Automated enrichment allows for a complete delivery overhaul without dropping a single position in search rankings. The second threat involves dynamic features. Many migrations break WooCommerce checkout carts or contact forms when the site moves to a static environment. Static caching typically speeds up a site by freezing it, but freezing a page inherently breaks live data, making it impossible to handle a real-time e-commerce transaction. Hybrid static and dynamic handling manages both types of data simultaneously. This is achieved through serverless Edge API proxies. Heavy page elements like images are served from static edge nodes, while dynamic user sessions and cart badges are routed in real time through the proxy. The real-time logs here demonstrate this hybrid flow, sustaining live operations even while the site handles thousands of visitors. These proxies maintain sub-45 millisecond load speeds without sacrificing WooCommerce functionality. The third threat is the update bottleneck. Content updates on large sites can trigger syncing delays that eventually crash the server. In many static systems, correcting a single typo requires the server to rebuild every single page across the entire website. AI-powered incremental builds eliminate this requirement. The AI maps the site structure to isolate and rebuild only the pages affected by an update. This surgical approach reduces deployment time, finalizing most updates in under 30 seconds. On the WordPress plugin dashboard, these builds appear in the recent activity log as content synchronized successfully, happening invisibly in the background. Incremental building allows enterprise publishers to update content in real time without the risk of an origin server bottleneck. The fear of migration is a direct result of an architecture that was not designed for modern performance demands. Forcing a live PHP database to directly serve heavy public traffic is unsafe and difficult to scale. A decoupled architecture places the vulnerable core inside an armored vault, while weightless clones are broadcast to the public. This turns the WordPress origin server into a hidden content management system, accessible only to internal teams. The public audience interacts with a pre-compiled edge clone distributed across hundreds of global nodes. This allows agencies to manage massive traffic spikes, reaching over 1.2 million visits while maintaining high speed scores. Teams can scale traffic to handle over 100,000 concurrent buyers without ever risking the stability of the origin database. Performance security comes from shifting the delivery model. By moving WordPress to the edge, agencies can protect their sites from the bottlenecks that cause migration failure. Visit Nimbica to test a risk-free migration today.